Alright, for 1970 AB1, we have this parabola y equals x squared minus 2x plus 3. It doesn't factor, so there are no zeros in there. If you wanted to graph it, I would just plot a few points. It has its vertex at 1, comma 2. And then we have this line. What we're looking for is an equation of a line which contains a point 2, 3, which is actually on our graph. And this line is going to be perpendicular to the tangent line to the parabola at 2, 3. And so in essence, that's asking for the equation of the normal line. Alright, I'm going to erase the tangent part so we can see underneath there. Alright, so what we're looking for then is to find an equation for the line. So that's the first thing that we have to do. Well, we know that the derivative is 2x minus 2, and at the point x equals 2, y equals 3, y prime is 2, and so the slope of the normal line will then be negative 1/2. So all we're really looking for here is the equation of a line. We have the point 2 comma 3, we have the slope negative 1/2, and we get y minus y1 equals m times x minus x1, and y minus 3 is equal to negative 1/2 x minus 2. If I wanted to solve for y, I end up with y is equal to negative 1/2 x plus 4. And so that really completes the answer to problem A, or to section A in this. I'm just looking for the equation of the normal line, and it is y equals negative 1/2 x plus 4. Now, for part B, what we want to do is to find the area of that part of the first quadrant which lies below both those lines. And so it's going to be that area there. Now, what makes this problem important, and we haven't done a problem similar to this, is that we really need to find, we need to split up this graph, or split up this area into two sections. So we're really looking for two separate integrals here. We have the area to the left of x equals 2, which falls under the parabola, but the area to the right of x equals 2 falls under the straight line. And so we're going to have to use two different equations for that. And we're going to have to find the x-intercept of the straight line. So setting y equal to 0, half of what number is equal to 4? Half of 8 is equal to 4. Now that section over there makes a triangle, and that's fine. To solve that with a triangular area, it's okay. But I'll still set up the integrals and we'll work that out. So our area is now the integral from 0 to 2 of x squared, integral from 0 to 2 of x squared minus 2x plus 3 dx, plus the integral from 2 to 8 of negative 1/2 x plus 4 dx. So basically we're looking for those two different integrals there. Finding the antiderivative of the first, it's x to the third over 3 minus 2x squared over 2, which comes out to be x squared plus 3x. And we're going to evaluate that at 2 minus at 0. For the second one, it's going to be negative 1/2 x to the second over 2. So that's negative, so that's x squared, negative x squared over 4. Plus 4x, evaluated at 8 minus at 2. So substituting, we get 8/3 minus 4 plus 6 minus 0. So it's negative 64 over 4 plus 32 minus the quantity negative 1 plus 8. I won't go through all that work, but that comes out to be 41 over 3. Alright, so sometimes, as in this case here, you're looking for the area under two different curves, and one part, part of the area is under one curve, part of the area is under a different curve. And so you have to use two different integrals to set that up. Just make sure that that's clear. The integration is not difficult. Understanding what to do there is very important though. And that's it for that problem.